Hey everyone, just wanted to give you a little bit of homework help on the similar right triangles section. I know this one's a little bit tricky, but maybe this will help you sort things out. Let's take a look at number 13 and then number 16, and hopefully this will help you out a little bit. Starting with number 13, we want to figure out what x is, the missing leg of the large right triangle. So we're going to use the geometric mean, the leg theorem, and our proportion that we're going to set up is going to be 9 is to x as x is to 5. You might be wondering where I got the 9 from. The 9 is the hypotenuse of the larger right triangle. And so what we're doing is we're actually just comparing the hypotenuse of the larger right triangle to the hypotenuse of the smaller right triangle, x, and saying that that's proportional to the leg of the larger right triangle, x, and the leg of the smaller right triangle, 5. So solving this proportion by cross-multiplying, we get x squared equals 9 times 5, or 45. But I can just leave it written like this, because when I take the square root of both sides, you can take the square root of 9 and the square root of 5, and then your radical is already broken down, and you don't need to deal with simplifying your radical. So x, instead of writing the square root of 45, you can see x is just 3 radical 5. So that's another little shortcut instead of having to simplify the radicals. So the answer is 3 radical 5. I'm going to break it down for you in a little bit of a different way, just so you can see how to set up that proportion. So if we take apart the larger triangle and the smaller triangle and draw them side by side, here's my larger right triangle with a hypotenuse of 9 and a leg of x. And then I'm going to draw for you the smaller triangle here, the one that I'm highlighting in orange, rotated side by side with the larger right triangle. And you'll notice this hypotenuse is x, and the leg, or the base here, is the 5. So looking at it that way, you should be able to identify how I set up the proportion, because these triangles are similar. Alright, so let's take a look at number 16 next. Okay, so in number 16, instead of looking for a leg, x is actually an altitude, or the altitude of this right triangle. So we're going to be using the geometric mean altitude theorem, and this proportion is pretty easy to set up. So what you want to do is take one of the smaller pieces, so in this case 4 or 9, and start with that. So 4 is to x, and you're always going to repeat the altitude. So that's always going to be the repeated part of the proportion. 4 is to x as x is to 9. Cross multiply and solve. X squared equals 36. Take the square root of both sides, and x equals 6. Voila. Alright, I hope this helped.